problem 6 of the exam review worksheet. It comes from chapter 5 in your book. And our job is to determine the voltage function for t greater than or equal to 0, given this circuit right here. And it tells us that the switch had been in position 1 for a long time until it was moved to position 2 at time t equals 0. And we're given the values of all of the elements. So let's take a look. Let's first draw it the way it would be at time t equals 0 minus. So at time t equals 0 minus, we have the current source, and this switch, let's see, had been in position 1. So this switch is closed. Now it had been that way for a long time. Sorry, that was my cat walking across the keyboard. I don't know how to get rid of it. Okay, there we go. All right, and it had been in position 1 for a long time, so that means our capacitor is acting like an open circuit. Yeah, an open circuit. And we do have our voltage source. And we have a resistor here. And we have that, which isn't doing anything. So I0 is 6 milliamps. And R1 equals R2 is 4 kiloohms. And the capacitor has 200 microfarads, but we're not using it right now. Okay, so if you look, this whole side of the circuit is open. So there's no current flowing through any of this. So if this is ground, and V0 is 18, then the voltage here is 18. Now the reason I'm interested in this is we need to find V of 0 on the capacitor. So Vc of 0. Now because voltage on a capacitor can't change instantaneously, Vc of 0 has to be the same as Vc of 0 minus. So that's what we're trying to get right now. So this side is at 18 volts. Now we need to figure out what this side is. So the only current that is running is right here. So that's our current. And since there's no current here, this is also at ground. Nothing is happening here. And we have a current source and we have a resistor. So we'd like to know what the voltage is right here. And I'll call that V. And so we know that V equals IR. Or we could do a source transformation on this and see what it was by doing a source transformation. But anyway, so we have our current is 6 milliamps. And our resistance is 4 kiloohms. And so a milli times a kilo just cancels each other out, and we get 24 volts. So this side of the capacitor is at 24 volts. So Vc of 0 minus is the difference between 24 and 18, so 24 minus 18 equals 6 volts. So that's Vc of 0 minus. Now let's figure out what Vc at infinity is. So, because we need that term as well. So now the switch is going to move to position 2. And this part of the circuit will be open, so this part will be irrelevant. And so our circuit now will look like, we'll still have an open circuit here because we will have gone to infinity. and this is at 18 volts. This is ground, so it's an 18 volt voltage source, so this is at 18 volts. And the other side is at ground, so we have that side has to be 0, and so VC at infinity has to be 0 minus 18 equals negative 18 volts. I'm taking the plus side minus the minus side. Okay, so last thing we need to find out is our time constant. And the time constant for an RC circuit is RC. So, and we're looking at this circuit here this circuit here after we've thrown the switch. And so in that circuit, R is 4 kiloohms. And C is 200 microfarads. Micro is times 10 to the minus 6. So if you multiply 4 times 10 to the third by 200 times 10 to the minus 6, you get 0.8 seconds. Okay, well now we're ready to determine the function for the voltage across the capacitor. So we know that V of t equals V at infinity plus V at 0 minus V at infinity e to the minus t over tau. So V of t equals V at infinity was minus 18 plus V at 0 was 6 minus negative 18 e to the minus t over 0.8. So that's minus 18 plus 24 e to the minus, now let's think of this as 1t over 0.8, and 1 divided by 0.8 is 1.25. So this is negative 18 plus 24 e to the negative 1.25 t. And that is our answer.